This is the eagerly awaited Euclid Book 4, proposition number 9. We're going to start this proof with a square, A, B, C, D. And we're going to circumscribe a circle around that square. And we're going to take this very slowly. First of all, we're going to draw a line from point A to point C. Then we're going to draw another line from point B to point D. And these two lines are going to cut each other at point E. Alright? Now, all sides of a square are equal. Therefore, line AB is equal in size to line AD. Okay? And of course, line AC here is equal to itself. Okay? And line BC here is equal to length BD here. Okay? These two are equal in length. Therefore, we have two equal sized triangles, ABC and ADC. Okay, these two triangles are equal in size. Alright, now we're going to talk about angle DAC. Well, where's DAC? Well, here's D, here's A, and here's C. And this angle right here is equal in size to BAC. Well, here's B, and here's A, and here's C. These two angles are equal in size. But in the future, in the not too distant future, we're going to talk about this in this video, we're going to say, instead of angle BAC, we're not going to say BAC anymore, we're going to say BAE. So angle BAE is the same as angle BAC. Likewise, DAE is the same angle as DAC. I've written this down right here to show you that. Okay? They're equal because they're the same angle. Alright. Now, again, line AB here is the same size as line BC here. AD is the same size as DC here. And we've established that BD here is equal to itself. So therefore, triangle BAD, BAD is exactly the same size as triangle BCD. Alright. So we now have angle ABD, which in the future is going to be referenced as ABE. Okay? And ABD is equal in size to DBC. This angle here is equal to this angle here. Alright? And this is by Euclid Book 1, proposition number 8. And we could go on with this and on with this and on with this, but we're not going to. Alright. Angle DAB. Well, where's DAB? Well, here's DAB is equal to angle ABC. Well, here's A, here's B, and here's C. Why is it that DAB, this angle right here, is equal to ABC right here? Well, because squares are equilateral and equal angular. That's why. Alright. Now, angle EAB, well, here's E, and here's A, and here's B. It is half the size of DAB. Alright? And we can establish this by saying that since these two lines cut each other, so on and so forth, these angles have been bisected, so on and so forth. Okay? And we can then go on to say that angle EBA, well, here's E, here's B, and here's A. It is half the size of CBA or ABC, either one you want to go by. Okay? Now, if EBA and EAB are equal because DAB and ABC are equal, and these two angles have to be half the size of those. Then we can go on to say, because these two angles are equal, then we can go on to say that EA equals EB. Well, here's EA here and here's EB here, and these two sides are now equal. Alright? And we can say this by Euclid Book 1, proposition number 6. Same deal. EAD, well, here's E, here's A, and here's D. There's the angle we're talking about right here. Alright, and let's see. EDA, well, here's E, and here's D, and here's A. There's that angle right there. Since this angle is equal to this angle, then we can go on to say that EA and ED are exactly the same size. Alright? And eventually we can go on and on and on, and you can do this for yourself. We can then finally prove that EA, EB, EC, down here, and ED, they're all the same size. EA, EB, EC, and ED are all the same length. Having said that, you can actually then take your compass, put it at centermost point E, extend it out to this outermost point D, or A, or B, or C, either one, and you can start drawing your circle, because these are all EA, EB, EC, and ED have just become radii of a circle. They're all equal in size, so you can use any one of them to start making your circle. And if you start your circle at ED, it's going to pass through EA, EB, and EC. Therefore, you have successfully circumscribed your circle around a square. I will tell you more in a future video, so stay tuned.